Okay, we have a MacBook Pro, and it's a low power, but they also give us a password in case we needed to be able to, in case we got it fixed, and yeah. But then again, this is not coming from us directly. So the client took it obviously to a company, and then the company now get it to us. So the device is coming in for no power, and this is an A1707. So usually when you see 15 inches like this ones, you would you know that uh, the 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 method of troubleshooting we use is it's fairly similar, the 15 inches and the 16 inches. However, there is an exception. The troubleshooting between the 15 inches A1990 and A2141 are similar, but not the A1707. The A2141 and the A1990, you have the common issue of 2.5 volt shorting to ground because of either C9081, or you have one of the NAND U9080 getting damaged, and that as a result, damaging sending out 12.6 volt on a supposed 2.5 volt line. So usually what we would do if it's an A1990, immediately we take out the back cover. The first thing we want to do is we want to check out the fuse to see if we have a short on PP bus. And if it's an A2141, we do the same thing to see if we have a short on our PP bus line by using the fuse. With the A1707, that's not the pattern that's expected. It's completely different. So this is a no power, and the same thing applies. We are not going to put power to it. So I'm going to show you guys with the A1707, the troubleshooting process. It's slightly different. Now, 9 out of 10, the PB bus line is not going to be a problem on the A1707 because it's not it's the failure pattern of the A1990 and the A2141 are not the same. So so with this one, we are not going to start by measuring for, so PP bus will be these two guys here. That will be your voltage on, that will be your fuses on the PP bus line. But we are not going to measure for PP bus because the A1707, 9 out of 10, you will not have an issue with the PP bus line. Yes, you still may have an issue on the PP bus line, but it's not a common thing. It's almost like, unless it's a liquid damage device, or there's something specific on the PV bus line. Other than that, you are not going to have a short on the PV bus line. However, the short you want to have, it's around here. Now you see these capacitors here. So these capacitors, it's a PP3V3S4, it's SOCS4 line. So there's supposed to be a 3 volt. It's a 3 volt three. These capacitors are sitting on 3.3 volt line. What happened is the same thing that happens to the C9080, because of the position of C9080 on the previous line, thereby collecting dust and then moisture, and then having to go through the process of failing. That happens to the capacitors around here, and then it's the same thing applies. Now what happens is, over time, the capacitors around here, they tend to just the same behavior of the C9080. So what you want to do first is you want to check out, I'm just going to see. Now you want to check out this line to see if you have a short on this line. That's one. The PP3V3, PP3V3 underscore, PP3V3 underscore S4 underscore SOC underscore PMU. Now that is where you want to check out first. And for that, you do not need to even take the board out. I mean, with the board in, you can easily take the board out. There's also another machine that we worked on that had like a similar failure pattern. I think the A2141 also sometimes will have capacitors on the edge that will also fail in that manner, which is on the top. That's the A2141. But the A1707. So usually, typically, what I would do is I will check out I'm not going to worry about the PP was because I know 9 out of 10 it doesn't fail. So when it comes to no power, by the way, and then some of the issues I'll be expecting is either I'll have a short on my PP3 before 2, or I'll have an issue with the PP with the CD3215s, which is the controllers for the USB-C ports. And commonly, I will check out here to see if I have a short. Now, on this particular one, I did check it out before because the client wanted us a quote. the client wanted us to code first before we fix. Uh, Okay, the client wanted us to code first before we fix. So we had to first of all check it out briefly so we can tell the client what the issue is and also code the client and then for them to also decide if they want to fix it or not. So I did confirm that we have a short on this line here. Okay, let's see. Yeah, now you see that, say this capacitor there, that's capacitor is sitting on the PP3V3 underscore S4 SOCPMU line. So if you have an A1707 and it doesn't turn on, and it's not a case of liquid damage or a drop damage or something that you can physically see, then one of the ways you can check it out is to see if you have a short on your 3.3 volt line. And with that, you don't really have to take the board out to confirm that you have a short. Now there are two things. The capacitor might be one of the ones here, and it might also be inside. But we have to take the board out to confirm because we don't see anything here that looks affected. Because if you see on here, the capacitors that are on that line are going to be 1, 2, 3, 4. This is a resistor, and this one. And we don't see any of that looks suspicious here, which means most likely the capacitor that's failed will be on the other side of the board. So we are going to quickly take the board out. We are going to start with T4 screws, and then now with this particular one, so the T4 screws on the cowlings, the ones on the trackpad and the keyboard are going to be the same. The one on the touch bar are also going to be the same in terms of sizes. And then this here will be slightly different. This here, the one for the touch ID as well as the audio jack will be slightly different. Now, obviously, this and that is the same thing, which is standard. That screw is not supposed to be there. That's a wrong screw. That's not the screw that's supposed to be there. So most likely this has been opened before, and yeah, either it was opened for this particular issue or for a different issue. This is the first time you're doing this, you want to take note of your screws, very important. And then the other screws, you see the ones for the touch ID here as well as the USB-C port, they are going to be of the same size. The ones that goes into the board, that, and the one that I took off from here, they will seem almost to be of the same length. So those two, because they are also T4. And now we are going to use the T5. Let's take out the battery screw as well. Okay, now we're going to use a T8, T10. Okay, now let's take our board out. We missed a screw here. Now you see how dusty it looks. Same pattern. See how dusty it looks there. So if we flip it over, it should be yeah, so now let's see which guy failed. So put the shell on the side. We are going to dust the board, give us a better visibility. This is a 2016 board, by the way. Okay, let's see. Is there any? Because the reason why I'm focusing my attention here is because if you look at that line, if I flip to the other side, you see more of that line. It's around here. Hmm? So I'm going to focus around this section here. So these two capacitors are sitting on that line, and they don't look too bad. Hopefully our issue is not going to be U4200. Okay, so what I'm going to do, because the capacitors that are on that line are going to be on this side of the board. You have C4204, C4207, C4202, and those three, those 1, 2, 3, they don't really look bad. And then on the other side, which is on the other side, we are looking at 1, 2, 3. On the other side, we're looking at 1, 2, and 3. So we're not sure which one exactly it's our issue. Or it could also be that we are having an issue. Let's see, there's a resistor there, which is going to be V3S4. Hopefully that's not our problem. Let's just quit this and open again. So I'm hoping that the issue is not going to come from the other side of the board, because here you have a current sensing resistor, which is R5610. On pin 1 of R5610, it's PP3V3_S4. So because of this, because now whatever is here, it's equal to here. So if we have a problem here, it's also going to show up here. So I'm hoping that the issue is not on that side, because you have more components on that side, and compared to what you have on the other side. Do you understand? Compared to what you have on the pin 2 side of it. So let's start by removing this capacitors, which is 1, 2, 3 first, and see if we get any changes. Just to confirm, so what we are getting is and this is the resistor, the section of the resistor that I was talking about, this one here, the current sensor resistor. So if you check here now, so black hook on ground, let's see, you see that bit, that's 0. And then on the other side as well, because whatever you have here, you will have on the side. So I'm hoping that the problem is on this side and not on the other side. So let's remove the capacitors. Actually, this guy here looks like the issue. The capacitor doesn't look so good. Yeah, this one here looks, uh, it, that doesn't look so good. So let's see if that's the guy. So we can read across the capacitor. If it beeps, it tells us that it's faulty. But if it doesn't beep, it means that's not, because being a capacitor is not supposed to beep on both sides. Nah, that's not our problem. That's not our problem. Let's take out the next one. Let's hope that is our problem. That's not our problem. So let's take out this one here. That capacitor also doesn't look faulty in any way, but yeah, just taking it out, but it doesn't look faulty in any way. Mm, okay, yeah, because I could actually see that it doesn't look faulty in any way, so I'm just going to put that back. And I'm also going to put back the other two. Okay, so on the other side of the board, we have these two here and this. And those also do not look faulty. So what I want us to do now is let's check the other side of let's see on the other side of the current sensor resistor. Let's see the components there and see if we can pick up anything on the line that could be okay. We have to close that again. The software is acting up. Okay, so let's see if we click that. I will show us places where S4 shows up. So we are going to look for capacitors. That's a resistor. We're not going to worry about that for now. Resistor, resistor. So you see, wherever you see R, that's a resistor. So resistor, resistor, capacitor. Yeah. So here we also have an equal to, which is R5650. So we also have a current sensor resistor there, and then on this side as a resistor. Let's go to the other side. So let's look for a capacitor. That's a resistor as well. That's a resistor. And here you also have the equal to PP3V3S4. Okay, and that side here, what do you have? Okay, you have capacitor there and there. So let's check that side of the board. This side, the two capacitors. So this and that. So these two capacitors are this ones here. So the two components are this, and the capacitors are this and that, and they don't look bad. So that's not likely our issue. And then that's a resistor, and on this side we have a capacitor on this side, but that also do not look bad. Okay. Okay, so we don't see anything that stands out. So what I'm going to do now is I'm going to just have a look at the board. Let's just go over the board and see if anything stands out. So usually when you have a short on your PP3V3S4 line, you usually have it sorted out around here. You will find one of the capacitors, especially around the side, that will that you just need to take out and you'll be good to go. But in this case, that's not happening. This capacitor, it's not looking good. Let's see what that is. So good. Okay. Yeah, we'll check it out. Okay, that's fine. That does not beep on both sides. Let's see. Let's see. Anything else that stands out? Anything else that stands out? Anything else that stands out? Mm, 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 We don't inject voltage. We're gonna see if we can. Uh, let's see. Okay, nothing stands out here. Okay, so since nothing stands out, say again. Which of that side? It's the same answer that I gave about. He's calling me. I'll call him back. So yeah, so since we cannot see anything on the line, let's uh let's okay. So even though that capacitor doesn't really look, but just because it's on the line, so we are going to remove it. Even though I don't really see any sign that suggests that it could be faulty. Let's check that. Yeah, nothing suggests it being faulty, but and also these two here, they look super clean, but yeah, and I also don't see anything to so we yeah, yeah, because they look very clean. So okay, so we see that this is taking a different approach. So none of the capacitors, none of the easy ones, it's our problem. So we have to do a bit more work. Okay, so that's been back. Now let's go to the other side again of the board. Let's see on the other side of the board. We know that okay, so on this side we have a resistor. Okay, and on this side, do we have any cap that we could possibly blame? Resistors or resistors on this side? Is also a resistor. Okay. Hmm. Okay. On this side, let's see. We did check but these small ones, they almost never fail. That's why I'm not bothered about them. They almost never fail. So that's why I'm not bothered about them. That's why I have a feeling that we might be having a different issue in a different section of the board. I mean, we might be having an issue with a different section of the board, not because the tiny ones almost never fail. Usually the ones that fail are these guys here. And let's see. And what about this too? Okay, that's 1.8 volt. Okay, let's look at the aliases. On the other side, we know this is equal to. So let's see on the other side of the board. Okay, this one here, what are you equal to? Trackpad. Anything that could stand out for us? Not really. Okay. Let's check this side again. On the other side. On the other side. And this here we have another current resistor. And okay. So let's see here, because we know whatever it's going to be, whatever comes here is going to be equal to into. So let's see what that looks like, that capacitor, this guys and this guy. So let's see this side of the board. And they look just okay. The L is an inductor, this guy here. When you see L, that's an inductor. So an inductor will behave like a fuse in terms of the voltage present. So whatever you have here in terms of voltage will be what you have on the other side. So if, so let's see, and then this guy here, let's see what does it connect to. Is there anything that we could potentially blame? Nothing. So, let's see. And then here it's this guy here, and this capacitor looks just okay. Okay, we might have to inject voltage. That's it. Okay. Uh, that's a 14 inches.
Yeah.
What's it?
Liquid dimension.
Okay, not a problem.
Today.
Okay, not a problem. I'll get back to you. It happened today.
No. I need to know just feedback about.
Okay, not a problem. I'll get back to you today then.
Inshallah. Thank you.
Okay. Walaikum salam. Okay, so this section here is looking clean. Nothing stands out. This is very interesting. So the board is looking clean, but we obviously have a short on the board and nothing is standing out, which is basically forcing us to inject voltage, which we didn't want to do. But yeah, we kind of have to do that. Let's see. And we just couldn't pick up anything else that could potentially be our culprit. Nothing. We don't see nothing. Do we really have to inject voltage? Yeah, we have to. Okay, it's just let's see if anything will give us a clue as to. Let's see. See if we get a short around something else. We did remove that, correct? Yeah, we did remove that. So it's definitely none of those three. Yeah, and PP bus is definitely not. So probably thinking maybe we might have a sub rail that. Yeah, I don't want to inject voltage, but yeah, we'll have to inject voltage. Unfortunately, we'll have to inject voltage. Okay, So we don't have a choice but to inject voltage. Okay, let's see. Let's check around here. Let's see. Hmm. Okay. Yeah, but unfortunately, we nothing stands out, so we have to inject voltage. It is what it is. We wish that was not the case. We wish it was going to be an easy one, but yeah, it turns out that it's not. It's not going to be an easy one. So now we are going to inject voltage to see if anything gets warm. I would have thought that the issue would have been simple capacitors around the edge and easy, but nope, we're not gonna get it easy this time. We're not getting it easy this time. Okay. Okay, so the idea is we are going to inject voltage on the line. We have one of the voltage the power supply, the wire, the output of the wire. So one wire will be going to ground, and then the 3 point, and then the voltage line is going to go to the line where we suspect or where we have a short. So we are going to gradually increase the voltage until something gets warm, and hopefully, so we are going to hope that this is not going to be an issue with the PCH or anything like a major component. So let's start over again. So we know that we have a short on this line, and if we even happen to have a problem with U4200, that is still okay, but U4200 don't wouldn't just die. I mean, without something happening around it, and yeah, okay. Yes, we unfortunately have to inject voltage. Okay, let's power up the machine. Okay, we're now going to gradually increase the voltage. Let's see what we get. Seem like a dead short, but uh, we don't see. And we don't get anything warm yet. Nothing warm as yet. Nothing warm as yet. I'm just hoping that it's not the PC edge. And also, it wouldn't be the T1 chip. U3900 is a T1 chip. I just hope it's also not the T1. I really hope so. Let's see. There's something seems to be getting warm in this section of the board. I hope it's not the T1 chip. So the T1 chip, let me say. I don't. What is getting warm? I guess is the wire itself. There's something getting warm around here. There's something is getting warm around here. Yeah, something is definitely getting warm around here. Let's try to increase it a little bit. Hmm. Something is getting warm around U4200. So what we're going to do is we are going to remove U4200 first because nothing else on that line. It's because we did remove so on around the 4200 we did remove practically almost everything there. Now I'm not sure if U4200 is getting warm because of the amount of power that we're putting through it, or it's getting warm because it's actually faulty. One way to find out is to remove it. So we don't have a choice but to remove U4200 and see what happens. Okay, U4200 is out. uh, I'm not hopeful that it's U4200. No, I'm not. I'm not, but Yeah, we just really have to remove it to check, but I'm not hopeful. Okay, let's see. Black one ground and then red probe. That's ground. The other side. Yeah, it's not 4200. Cause I mean, yeah. So if I yeah, it's not 42. Then what is it? If it's not 4200, then what is it? Um. Hmm. Let's put it back. So let's check it again. Hmm. Okay, so we have to wait. Okay. Okay, let's see. Anything getting hot around here? It's still getting warm. Okay, so let's the we already did take out the capacitors there, so let's remove them again. I mean, we see that something is getting warm around that side. So let's also remove the small capacitors, the ones that we we obviously are saying they usually don't fail, but given let's see, let's remove those as well. So it's this one here. I'm just going to push it aside. I don't have to remove it, and that one as well. And this guy, I'm just going to push that also aside. So let's check. Hmm. Yeah. So which one is it? So one of the companies that I took out now, it's the problem. But which one is it? This because okay, let's see. Now is it this one here? This one? Let's check that one. Not that one. Okay. Let me remove those two because I'm very confused now. Okay, so let's check this one here. How? Yeah, but this is it beeps, which means it's faulty. But how is that possible? We did take it out before. It was the same one that I said that it looks like the guy that is faulty. We took it out, we measured it, it didn't beep, and then we measured the board. There was a short on the board still. Let me see. And on the board now, we no longer have a short. So what happened? Um, because we did confirm. I mean, I remember I did take this out, and and there was I took it out and I measured it, correct? I measured it and then the short was still there, which is why we had to go this far and take out all of other components. Now 3.3 is the same line, the 3.3. The this one here is this one. Is this one C42 4206, which is the same one that we. There's this guy here. I don't understand how. I don't understand because we did check it and we did check. I'm just gonna get another book. We did check it and what is it? Uh, he's gonna come upstairs. He's calling you or me? Was he calling you? Oh, um, he has to come upstairs. Um, okay, now so let's just confirm that the shot is gone. But this is very interesting. I'm not sure what happened here, but Yeah, the short is gone. Okay, so we now have to put back U4200. Okay. Okay. So I'm trying to get the orientation right. Okay. So I hope the soda balls underneath it are not crumbled underneath, because you usually get that, and especially BGA chips. Okay, so I'm just gonna check again to be sure we don't have a short. This is very interesting. So we might have to redo U4200. Yeah, sometimes you don't get it right the first time. You have to do it again. Let's see. Okay, I'm sure it's gone. So we are now going to see what we have on the line. I'm just gonna get your phone. Hello, Yannick. Hello, can you hear me?
Mike is trying to get hold of you.
Can you please ask him to come upstairs?
I think because of where he's parked.
Okay, just tell him to wait then.
Okay.
Yeah. Okay, so let's test this first. This is very interesting. Okay. So connect charger. Let's see what we have. Let's see what we have on PP bus. Do we have 12.6? That's good. It means we have 20 volt on our PPDC in. Now let's check on that line. Do we have 3.3 volt? We have 3.3 volt. That's good. It means that the device is going into ISO state. But now, okay, so let's quickly see if U4200. So U4200, if it's not properly installed, what will happen is the device will have issue. The device will not boot to desktop. The device will be able to boot to recover. You can boot into safe mode, but you cannot boot into the standard operating system. So, which will mean that we'll have to redo U4200. So let's hope that U4200 is properly installed. But right now the board is going into SO state, so we are just going to quickly see if we can get the board to boot in regular mode. Then we know that U4200 was properly installed. But if we get a critical update, then definitely we have to redo E4200. But right now, I'm pretty sure the device starts because we did measure SO rails. So let's see. It says very interesting because I'm not sure what happened there, because if that capacitor is the one that failed, we did test it before, and eh, which we wouldn't have to remove the 4200 or go any further, which is, but yeah, Allah has it that we have to do it that way. Let's see. Still need to clean the board, but right now we're just going to see how the board behaves. So you see the fan is starting. Did it just go off again on us? Okay, we have fan screen. Have anything on the screen? Uh, okay, we have a chime. We have Apple logo. Let's see if it boots the desktop without saying anything about critical update, then we could. Then it just is. Let's see if it asks us to connect to the internet, then definitely we have to go walk around U4200. Let's see. Let's see. Uh, that's a good one. That's good. Also, alhamdulillah, that's good. Okay, E4200 was probably so. So what we are now going to quickly do is we are going to, because actually the owner of this machine is downstairs. So yeah, we just need to quickly clean the board, and yeah, so what we're going to do is we are going to clean the board and then put the device together. You guys saw that the device is working and we're able to boot the desktop. So Shahid is actually going to go tell the owner to be calm while I put the board together. But other than that, you guys saw that the machine works. Thank you guys. I'll see you guys in the next one.